Hello, welcome everyone to this session in our webinar of the Vision Zero Challenge. We're really glad to have you here. And well, today's seminar is about the visibility in urban traffic. It's by 3M. We're really glad to have them here to speak about this subject, which is so important, which is visibility in urban traffic. And we also welcome 24 cities that belong to the Vision Zero Challenge. We are here with you once again, like last year, with a few other cities. We welcome you. We'd also like to thank all our partners of the Vision Zero Challenge, the FIA Foundation, Gonzalo Rodriguez Foundation, the IDB, VS Latin ANCAP, Towards Zero Foundation, Vision Zero Academy. They gave us several good, important webinars the last few weeks. UK8, GRSF, World Bank Group. We also welcome our sponsors for the Vision Zero Challenge, 3M, PTV Group, and the Volvo Group. So now I'm gonna pass the floor to our friends from 3M so that they can present about this subject. So thank you very much. Good morning. It's great for us to be able to be here with you. For us, Alejandro, thank you very much for the chance to share something that I think that unites us all, which is the Vision Zero Challenge. And I wanted to just mention that we're thankful for the commitment of each of the cities that are represented here in each country by this challenge. I think that it's one of the things that at the end of the day they try to push forward and continue pushing forward to be able to save lives every day. Yeah, we live in a reality that is strange because everyone is stuck home. The distancing in a lot of ways, and unfortunately we see that societies and economies, they start to reintegrate themselves into the vaccines, but unfortunately we do not have a vaccine or a social security matter that we can start applying. And we need to count on the commitment of each of you and your governments and your management that will be able to make this a reality. We're very thankful for the chance of sharing on the 3M perspective what this vision is that we have with our technology, with our technical assessment, to be able to accompany you on this path looking for safer cities and streets. So can we please go on to the next slide, please. First I want to present the 3M team we're going to be sharing with you today. First I'll start with our engineer Maria Lourdes Mogollon. She's in I don't want to present yourself. Yes, good morning everyone. You can call me Mali Mogollon. I am Peru. I'm an engineer for applications of road safety of 3M of the Andes region. Thank you. And also I'd like to present Paula Brew. Please, Paula. I'm an economist and lawyer. I live in São Paulo, and I am responsible for government actions for Latin America for road safety. Good morning, everyone. Thank you. And then we have Salvador Morales. He's also with us. Salvador, can you please present yourself? Hello, good morning, everyone. My name is Salvador Morales. I'm an application engineer for road safety for Central America and the Caribbean. Thank you very much. And Michelle, you can present yourself. Good morning, I am Michelle. I work in Brazil for 3M. I'm part of this great team. Thank you very much. and good to meet you all. Thank you, and I'm Victor Cabrera. I'm Mexican. I've been in the company for 24 years, and I have the role of Director for Road Safety and Transportation Safety for Latin America. So let's go on to the next slide, please. So the agenda we want to share with you is here. If you want to go on to the next agenda, not to go into too much detail, I want to talk about 3M a bit. What is our vision? Our vision is founded on technology, products, and innovation, which we are trying to develop and improve the quality of life that we all have in our companies, in our homes, and in our day-to-day lives. And a few of our strengths: we are a manufacturing company, we're technology-based, 45 technological platforms with which we have more than 75,000 products on a worldwide level. We have capacities on a global level. We have presence in a lot of the countries. We're going to share a bit of this. We have a very strong brand, and it's backed up by a lot, which has been for more than 100 years through history. Our priorities are to continue improving our portfolio. We have given priority to the priority segments that we have in the division of transportation and road safety, innovation, and people and culture. Our values that we are founded on is inclusion, diversity, sustainability, respect, motivation, and always we try something that when I went into 3M, they told us we had a space to innovate, 1/4 of innovation. The truth is, no, we are always trying to challenge ourselves to make it so technology can make better products that can improve the life of every person on a global level. So let's move on to the next slide, please. 3M was founded in 1902. Minnesota, USA manufacturing. It's based on the US. We have a presence in more than 72 countries. We are more than 90,000 employees and more than 10,000 scientists. Can we go on to the next slide, please? We are grouped in 4 business groups. The first one is the biggest one, security and industry. We belong to the business group, electronics group, and we are also in the business group of health group, and maybe one of the brands or the product line where people are more familiar with this reason 3M is the consumption that we see every day on the supermarket part. We can go on to the next slide now. One of the things that fills us with pride is this type of knowledge. For 3M is the way of thinking, the binary thinking. It's black or white, so we always try to never compromise our behavior, our ethical behavior. So we've been receiving this recognition for many years as one of the world level companies that is most recognized. So with this, I want to pass the word to Malu so we can start with today's presentation. Thank you very much for the opportunity once again. Thank you, Victor. So today we will be speaking basically about road safety and infrastructure, and also a bit about vehicles towards the end of our presentation and how these high visibility technologies are framed inside international initiatives towards Vision Zero to be able to reach 0 fatalities in our lives, and also lined up with 2 very important initiatives that we have today, which is the new executive action for road safety from 2021 to 2030, and also that we work and that our technology is to be applied to prevent injuries, high visibility, and we will see further on it helps the prevention of fatalities. This will generate a reduction of injuries, and at the end, the main objective is to save lives, stopping crashes, from prevention up to limiting the impacts of the crash. So we know that the main cause of crashes on the streets is related to human factors such as recklessness. They can be to consumption of alcohol, use of cell phones, distraction, excess speed, and also a lack of use of safety equipment. And of course, there is a deficient infrastructure. So in a way, this would aggravate the road accidents. So in a certain way, having high visibility, we can improve this. You can also see climate factors that can be adverse and how we can influence the human factor to reduce these failures or these errors that can be committed by people with technology. We know that this high percentage in human factors is a lot of the time the responsibility of users with excess speed, drink, and the use of cell phones or the lack of use of equipment as we mentioned. Then we also have a factor which depends on the vehicle. The vehicle needs to have active and passive security system to reduce the impact of the crash, and we will also focus on this 30%, which is related to the infrastructure itself and how we improve this infrastructure to have some kind of impact on the human behavior. So now we will pass to our engineer, Salvador. Thank you, Malu. So as Malu was saying, the infrastructure, well, it also has an important role, especially in this concept of how to make roads safer, keeping in mind that they are designed for humans and humans are susceptible to committing mistakes. Next slide, please. For this, it's important to have to clear this self-explaining roads concept. What are these self-explaining roads? Well, they're basically roads that help people to make better decisions. They reduce essentially the amount of confusion, the amount of information that the driver needs to have available. And with this, we managed to reduce this human factor that Malu was explaining. So what do we look for with explaining roads? Well, during the day or during night, they will pass the same amount of information. And why nighttime? Well, as you can see in this chart, that in this case of the National Office of Traffic Safety of Guatemala, well, during night, 2 out of 3 deaths happen at night in periods of low visibility. So next one, please. And this is related to this process, this cognitive process, how humans interpret what they can meet in the road. And for this, we've seen that not always what we see during the day is going to be visible during the night. The visual information is reduced, and only 5% of what we see during the day can be seen by human eyes at night. That's where we get different types of technologies that will help us to have this concept of a self-explaining roads. You can see in the next slide, for instance, how in a conventional road with good weather conditions, we can have this viewing distance up to 1,000 meters. When you're moving at nighttime, well, you can also see obstacles when they're 35 meters away from the driver. A lot of the time, this distance is not enough to be able to stop the vehicle, to be able to reach an impact. We're going to see how this works in this cognitive process for humans. Humans, as you can see, they have as a fundamental tool their eyesight or visibility for their decision-making process. The cognitive process happens when a person can start having a perception of the elements that are there, to be able to start associating risk levels and to react. Usually this perception and reaction time during normal conditions happens between 1 to 2 seconds. Afterwards, there is the whole physical execution of the maneuvers that the driver must take, or the adaptation that the vehicle must take. These braking distances, they say that the capacity that we have or not of causing the harm. The braking distances are different in dry conditions than in wet conditions. So we are subjected to laws of physics, and we require higher distances. For instance, 40 kilometers per hour, according to this chart. the Queensland's government, Australia, you can see that at 40 kilometers per hour, we need 17 meters and 2 seconds to take a decision, but plus 13 meters to have braking distance. So this adds up to 40 kilometers per hour. At least we will need 30 meters to be able to have this braking distance and avoid some kind of issue. So if we notice that the speed increases to 90 kilometers per hour, the decision-making moment and the distance of the perception, 38 meters, will be moved through, and braking distance 45 meters, and dry conditions 65 meters. In wet conditions we can see that distances increase. So what does technology do? Well, technology needs to be applied on different elements that we meet on the roads, as channeling devices, signaling, warnings, vehicles, especially large vehicles that move slowly, the personnel that is present in the road. And recently we've noticed the increase in the need to improve visibility for vulnerable users. So the cognitive is related to the capacity of we be able to have an adequate reaction time. In the next slide, so basically technology that 3M is pushing forward is increasing the reflectivity. Retroreflectivity. Retroreflectivity is the light effect which bounces on visual elements which are designed to be able to push back light in the same angle where it came from. And through this effect we make it so a signal like a stop sign will be able to reflect the light that comes from the cars, the headlights. It will go back to the driver on a cone which is called the reflectivity cone, so that this light will be more intense. We will have a better chance of improving perception times, and so the types of reactions for drivers. In this way we improve the cognitive process. So this retroreflectivity, as we've seen, is applied to the different elements that compose the road system. Humans, devices like cones, vehicles, high visibility close markings on the pavement. They have retroreflectivity that are minimally required because they incide directly on safety. So for this, we see the next slide, we will see how technology has an important role, because not always everyone will have the same level of performance, and not everyone can make it so these roads meet the need to be self-explaining. See next image, we can see different stop signs with different elements that will not be able to always provide the right message. So for this, it's important to be able to understand in the next slide how technology is important, and there is an evolution of this technology from 1940. Invent this technology, this reflecting technology, how it has evolved in different materials. There are materials that are used for commercial applications that are not used in roads. For instance, on the engineering materials, like they can have a 8 to 10% efficiency. Then there is materials that commonly they evolved from the engineering degree, which have 30% of return of light. These are known as high intensity or prismatics. This is technology that we can still see in urban areas that are used towards visibility at a high distance. And finally, the best technology, or the more efficient up till now, is the diamond grade cube technology. This uses a platform called macro replication, which you can have an efficiency to have about 60% of a return on the light for users. There are a few examples that we can see onwards through Malo, how we can apply this technology in road safety. Next slide, Malu. So Malu will be able to how we can improve perception times and reaction times, adequating themselves to the signaling with a high visibility technology. Please go ahead. Thanks, Salvador. So now we will comment a bit on the use of technology of Vision Zero and road safety. We've seen that with a new decade of action, the next decade, we've had Vision Zero with a focus on breaking paradigms and a traditional focus and help us to think about how we integrate human error and focus, like Salvador mentioned, driving a vehicle, being a user, be it a micromobility, a bicycle. There is a cognitive process, and this cognitive process, the same characteristics in the person, they can make it so the person will commit errors. So how do we integrate this human error into this focus of a Vision Zero focus, and how do we help to reduce the possibility that a person will commit mistakes through the technology that will help the infrastructure to be more visible and so prevent these crashes? So this must be starting from the focus, system focus, from the design focus of how we integrate this technology to constant improvements that we're having in our lives, and we will realize that at the end these deaths are preventable and we can, through technology, reach a percentage of reduction. Of course, they will not be the only measures, but they can help a lot and to save lives. Like mentioned, Zero says it's not easy. So breaking these paradigms through technology is key in these times. And we've also seen how Victor said that the world has changed. These last almost 2 years, we've had a lot of trends that had in a way come from have increased in the root of the pandemic. Rodrigo, can you please turn off your mic on WhatsApp? But we also know that there's a big chance to work and middle and long term how we move within our cities and how we can improve our infrastructure in a lot of our countries, how the infrastructure has changed the use of soil, giving space to cyclists, when we permit mobility, and in a way how the public service has been limited, the transportation system, and we've opted for other means of mobility, which will have difficulties because they are sustainable, they are ecologically friendly, and they can also have an important participation within our urban mobility. So today we know that a lot of you as global governments are focused on how to promote these forms of mobility, how to help if that they are safe transport modalities, and how this can be integrated into public transportation systems, making it so the operations become integrated. So in a certain way we'll have more inclusive cities and more safe and healthier cities. So this also, as from Wolf Roads for Life, that is an initiative that will help a lot to have low speed zones. When we talk about low speed zones, we are talking about places where mobility is limited to 30 kilometers per hour or less, where we can protect the people that transit, where we can live through different types of users, where we've had seen a limitation of participation, where we've seen that they have not been a priority for many years due to the laws that give priority to vehicles, and in a certain way to have places where we can place people and on cars and in the same environment, and we will have healthier and safer roads. And for this, the trends and the challenges are, and how do we transform these cities? How do we make them more inclusive? How do we generate spaces where other types of users also have the same rights and the same responsibilities? And we can have a safe interaction, which is what we're looking for. safe action where we can reduce the number of crashes. Sadly, when we don't have this type of transformation in a lot of cities, we've seen an increase of the use of bicycles, for instance, a direct proportion of increase of fatal crashes related to cyclists. So it is key to alter the order and how we drive our cities, but in a way that they promote the use and they do not have these crashes in a large amount. So thinking about infrastructure for people, as WRI says in their Safe Cities by Design book, where they need to redesign roads with the objective of having the needs of all users included, especially for those that perform other public activities. Working today with zones or low speed zones will have benefits on health, on the quality of the air, on safety, on the environment, on equity, and will also promote that public companies private companies will work towards developing and the innovation of solutions that can reduce this possibility of crashes. Basically, this is because we know that speed kills. There are studies that prove that there's scientific evidence that shows that speed is a factor that causes most of crashes, and when we have vulnerable users like vehicle users, the possibility of death can be even higher. So a vulnerable user, a cyclist, does not have the car's armature that protects them. They don't have the active elements that can reduce the amount of. So a speed at 50 kilometers per hour, the possibility of dying can be higher than 85%. While if we work with speeds of 30 kilometers per hour and design our roads, redesign our roads to have this type of speed, this possibility is reduced up to 10%. So to have zones or safe roads in a certain way will be a solution, like a low speed solution, to be able to reduce the possibility of death. And we also see that a lot of these initiatives and a lot of guides, a lot of books, especially the latest ones, which are the Safety Cities through the design of the WRI and the new guideline for low speed zones, WRI and GRSF, we can see a few recommendations of elements and devices that can be utilized to reach the desired speed goals, to reach these low speed streets, to reach these low speed zones, where we can in some way give back mobility to a lot of users that have lost autonomy, like children, the elderly, cyclists, people with impaired mobility, and in a certain way give them back autonomy, because we know that mobility is a right that a person must be able to function independently. If we manage to implement these elements, these devices on the roads, on low speed roads, we will be able to give back this equity to our cities. In a certain way, this will include them within a mobility process that bit by bit must be improving. So how do we relate these recommended devices to the technology that can be offered today by 3M? Well, we've worked studying the guide a bit about low speed zones, and we see that they are easy to implement solutions. They're fast to implement their solutions that can bring a large impact on the population, and especially with a low budget, you can actually reach several points that maybe today will be critical to our cities, and especially we will have the highest amount of accidents that will be able to give them priority. So elements and devices such as markings on pavement, markings that are visible, that are durable, markings that will be able to reach the vehicle drivers, physical signals that are coming into a different environment, that are entering an environment where we will need to communicate adequately the speeds and also be able to warn about what is to come. So the pavement marks have a fundamental role, not just vertically, but signaling is actually the only means of communication that the road has with its users. So if we work with good signaling, vertical signaling, it's not more or less important than signaling on the pavement. So they both needs to be used within roads to be able to communicate adequately 24 hours per day, as Salvador said. There's no point in having visible signs only during daytime. If during nighttime, which is when conditions are less favorable, they will not be visible. So on top of that, if we add climate conditions, weather conditions that can be even less favorable, like fog and hail or snow in some cities. So the marks on the pavement, be they uh, lengthwise or not, text, paint, they will help communicate in an adequate manner. We also have the warning signs, which is what will warn the drivers or preventing signs of the upcoming changes that will mark their decision-making caution. This is very important because with these we'll be able to warn about the presence of pedestrian crossings, bike lanes, the presence of school zones, something that the fact that we'll be able to prevent a situation where we'll be able to meet vulnerable road users, and you will need to have a better managing and ability to maneuver with less speed to be able to avoid crashes and accidents or collisions. So finally, we'll be talking about speed limit signage. Will be include signs that obligatory that will warn about speed limits. We've talked about this for speed limit being 30, or signs that say that the max speed is 30 kilometers per hour, and they'll be able to complement themselves to marking on the pavement, as we see in the image to the right, where both will be communicating the exact same message. We also see other types of situations or elements and devices that recommend this, that are part of this bibliography, where we can see the need of generating lane narrowing. A lot of the time, of course, this type of implementation must be assessed and analyzed depending on the type of road you have. But we also want to communicate, but it's not just about implementing physical measures when it comes to building. You can generate lane narrowing with elements, with marks on the pavement, with high visibility elements, then in a certain way will warn the drivers to not accelerate, to keep in mind that when you're moving through these strips that are straight, to make sure they move through at slower speeds. So in this way, lane narrowing will be helping a lot to have these considerations. This also, as you can see on the image, it's a school zone, and this in Panama it is added to school zone signs and high visibility elements. High visibility junctions, like crosswalks, must also be highly visible to establish pedestrian traffic on streets. This can also be implemented by whatever infrastructure, and stop zones, zones where the vehicles must insert in a certain way, reduce and stop in certain intersections to be able to allow for the passage of other types of users and minimizing risk. So through technology, high visibility technology, actually you can implement a much higher amount of infrastructure. If we can work through the redesign of cities with these added security measures, that can bring us great benefits for cities. Keeping in mind all of this, that human beings are vulnerable and we make mistakes. For a long time, the focus has not been on vulnerable people, but on individual responsibility, and in a certain way, the road must forgive these mistakes and must not punish you with death or with a serious injury. So you can see how one of these places that are prioritized to reach an efficiency with results and technology and reach these low speed zones are school zones. School zones must be safe places to learn and travel. Now we talk about the kids They have lost a lot of time, their mobility and their autonomy when they move around. We can see that Latin America, despite not having priority because really vehicles that are included in school zones, they still have priority a lot of the time. Kids need not just to move around safely and autonomously, but the means through which they move, it must help them to become better citizens, to learn and educate themselves as citizens in some near future. They will be using the road as drivers, as pedestrians, or as cyclists with another degree of responsibility. So we know that children, due to their physical and psychological conditions, they are more vulnerable to road collisions, and this also influences their movements, which are not that predictable. The behavior of a child on a road is not the same as an adult. We can't expect them to have the same behavior, and we must help the infrastructure to be safe. We also see a lot of the time that kids in their school classes and their courses, they have situations where they learn what a street light is, what a pedestrian crossing is, what signaling is. But when they go to the road, this reality doesn't exist. So they learn something in school, but when they leave towards the reality, they face something that is completely different. They see a road that is completely aggressive towards them, which a lot of the time the the stoplight doesn't work, or there's not enough time, where there is no pedestrian crossings, they have been erased, they are not visible, and there are elements that do not allow them to have safe transit. That's why we say that school zones must be safe zones to learn and travel. Especially in countries like the ones in our region, Latin America, where we see the statistics before the pandemic. I mean, the pandemic everything's changed because we still have not returned to normal to make use of school infrastructure. We had statistics that said that daily 50 children died, school-aged children, due to road crashes. So 50 children. And we see this reality we're talking about. Having two empty classes, 25 children gone, are empty because the day before they passed away on a road crash. So a kid does not drive an automobile. They basically move by foot, public transportation, or they ride a bike. It's not fair that their lives are lost in a way that they probably were not the ones responsible for the crash. So what are the most representative issues that we see in school zones? Starting with the behavior. Inappropriate behavior from the parents, mobility or school transportation, other types of users, and the students as well. They can see signaling that it isn't very visible, that is outdated, or in a certain way may be missing. As I mentioned, there is a lot of priority given to the vehicle and not other forms of mobility. We still need to integrate in a lot of cities bike lanes within the school environment so that the kids can move around on their bikes. Speed limits are not respected. We see a presence of public transport and unauthorized stops, which generally makes that the school zone collapses. We get commerce, moving commerce, informal commerce, and makes chaos take over these places. Infrastructure that may confuse or promote human error. In a few cities, also, there are unfavorable weather conditions that will impair visibility. This is not a lot, but we can see that there are a lot more problems that can be happening in school zones, and they may not be visible, or we normalize them to the point where we don't see that this reality may be directly affecting the students. So we can see that students are vulnerable users in Latin American countries. Statistics say so. And we can also see that the work being done in school zones needs to be multi-sectorial. It needs to be work where we have the support of schools, where the Local governments and municipalities will add themselves to the project. Traffic police will intervene to manage right enforcement. We need to add private companies and the community to be able to get results, and these results in a certain way must be communicated, socialized, so that the school environment can have a complete security. The type of implementation that are recommended within local governments having so many school zones or so many schools, the measure is to have a budget that will be enough to attain the implementation of several points where we can also have results that are visible, that will manage to reach the goals. You could start with the installment of signaling, marking the pavement with infrastructure that in a certain way will appropriate the space and give visibility to what is happening in this zone. On top of that, improve the measures that are related to traffic management and enforcement, and we also could manage to get the intervention of public spaces through the transformation of the road geometry to be able to manage these low speed zones, widening sidewalks if it is possible, the creation of school crossings, and so forth. So we see that in a certain way, if you prioritize matters, you'll be able to get short-term, middle-term, and long-term results. And the infrastructure that we recommend to give priority when we have vulnerable users, such as school children, you need to keep in mind the physical and psychological characteristics that kids have. Due to their size, maybe they can't cross a whole road at the same speed as a grown-up, as an adult. So the streetlight timing must be regulated so that a child can cross the whole street. Also, intersections need to be safer, crossings need to be safer. You need to promote lower speeds with vertical signage. We also need to keep in mind that due to the way they think and due to the way they imagine things, they are not as well capable as to judge speeds. They think that they can be faster than the vehicle, so maybe they could add some sort of device to make these children cross in a safe manner, and in a certain way will be able to walk through zones where they are allowed to. When we think about signaling, what must we signal? Approximation zones, parking, speed control, road narrowing, bike paths, medians and pedestrian shelters, school bus stops, and at the end, always note what the start and the end of the school zone is. Also, technical urbanism in school areas that must be related to low-cost engineering, where in a certain way we can also increase the visibility of intersections, like in this example, where the children will know that this is where they need to cross, and you can see that increasing the visibility, the perception of drivers can happen at a higher distance, must be a lot faster, and in a certain way they can locate the crossing zones that the kids can cross in a safer manner. Other proven countermeasures within urban mobility that can help us to have safer mobility with the implementation of high visibility technology. A few examples we can see, we'll mention, are sidewalk extensions, mid-block crossings, the bike lanes, and intersections. When we speak about curb extensions, we're talking about making use and appropriating a little bit of the intersection to be able to manage a safer crossing, to be able to increase the turn zone of the vehicles, reducing the speed of the vehicle within the intersection, and giving way to zones where micromobility users or bike users or pedestrians can be more protected against blind spots, against the speeds that vehicles can have in this intersection area. So we can see how the corner of the sidewalk is extended with marking with these posts and with markings that will have a high visibility. So this type of appropriation, the usage of these spaces, this helps to calm traffic. It will have lower speed zones. It will reduce. It's space dedicated for everyone, especially protecting the most vulnerable ones. There are simple and scalable solutions. You can increase them to use higher intersections city, and we can say that they are budget friendly. So this is within the recommended areas. In several guides you can see these guidelines. And this is also a manual from the New York City, where we can already see the implementation of this type of solution. And we can see that we have this increase towards the sidewalk, the visibility angle of the vehicles make it so that the cyclists will not fall into the blind spot. So by increasing the area, we can see that the blind spot is no longer an issue. So the driver will be able to see the people that are crossing, and they will give them more time, and they'll be able to perform brake or speed lowering maneuvers so that they will not have a collision. You can see another photograph from NACTO as a source where we can see this type of implementation, like road signing and increasing the pavement area. Another type of solution that must also be observed, studied, and analyzed is when, in a certain way, we observe the human behavior. In this case, they may be on blocks or roads where the intersection is too long, and the natural behavior for people makes it so that they cross. They essentially jaywalk. In this case, we will have to implement in a certain way, formalize the use that is really being used to know how we can add to this. Not just explain the crossing, but make it truly visible. To implement the signaling, vertical signaling, mandatory signaling, where we will have to reduce the speed. We'll mention that there is a crossing here with traffic calming measures, which can be a simple and easy to understand solution. In a certain way, it will promote this natural behavior that was already being utilized. So we can see how the before, which is an unsafe crossing where vehicles basically need to watch for pedestrians crossing, and then after, where we can see the crossing that has a speed bump. At this space, you can put a middle lane, a safety zone, to promote it being a safe area. You can see another region. Here we have implemented a reduction of the lane to improve the lower speed. So keep in mind that all these implementations of signaling that happens in these places, it's always recommended to use fluorescent coloring. In a few guidelines for a few countries, the warnings for pedestrian crossings in school zones and bike lanes, it's in the regulation, it's in fluorescent colors, but it's not every single guideline. So it's always recommended to use fluorescent colors because they are a lot more visible daytime and nighttime, and they will also be able to push back UV light that is usually invisible to our eyes, but will promote the visibility times. The recognition times will be much faster, and it will also warn the driver at a higher distance than on the road. Finally, about intersections. We need to keep in mind that intersections are generally the most critical points. It's where most crashes happen. It's where most deaths and most serious injuries happen, because they hit each other, the vehicles hit each other on a 90-degree angle or straight on. So we've had research that says that implementing roundabouts is an effective measure, but there are cases where we simply cannot implement a roundabout. So we recommend that the intersections we must help them to have more visible pedestrian crossings, be they with the use of streetlights or not. Don't forget that we need vertical signaling, we need pedestrian crossings. Don't forget we also need to have segregation elements, so to speak, for the crossing of micromobility vehicles or bicycles, and horizontal signaling that will improve the visibility of crosses on every weather condition. And also bike paths. We know that in a lot of our cities we have emerging bike paths in a certain way. They have happened because of the pandemic. But this must not be lost. We just not forget the need to separate cyclists, because putting them all together with vehicles on roads so we do not have a reduction to speed limit, you're combining a road with different mass sizes and different speeds that will cause in the end more serious crashes. So they must be marked out, they must be completely separated, where we'll have easy to install elements like vertical signaling, separating elements, and of course pavement marking. So up till then, as we've said at the start, we were going to talk about this application of technology in the infrastructure, but we also see the need of speaking about this high visibility implementation on the vehicles themselves, especially on vehicles that are now growing within our cities. So generating a higher demand, for example, the usage of motorcycles. In a lot of our cities, due to the need of transporting in a faster and safer manner to avoid becoming infected, or due to the popularity of delivery or home delivery services, we have an increase in the use of motorcycles. So when you increase the use of motorcycles, we also see an increase on road crashes that are related to this sort of vehicle. So when we talk about bicycle or motorcycle users, you must note that they must always be visible. Since they are more vulnerable, they must be seen under more critical conditions, especially in blind spots, when you're in an intersection, in low visibility conditions where public lighting may not be quite as visible. So in this case, it is always advised that the vehicle itself, the equipment that the rider is wearing, how other types of elements must have visibility. We're talking about the use of the jacket. In some countries it is enforced by regulation, but if you don't use a high visibility jacket or dressing, well, the vehicle itself must have this element as well. So with this, we always recommend the use of these strips, these reflective strips that we use for signaling, but of course they are modified to be utilized on vehicles that are more vulnerable, such as the motorcycles or the bicycles. In this case, we can see how these elements will promote higher visibility. They will guarantee especially the lateral visibility of the vehicle. When we look at a parallel between large size vehicles, that by themselves they have a regulation that must be followed when it comes to the obligatory use of reflective strips, or they are made aware that these reflective strips will help to avoid collisions. And we make a parallel with the motorcycles, we can see that the reality is very similar. Trucks or large size vehicles, passenger transportation vehicles, become a very serious obstacle on the road when you don't see them. So on the other hand, for other types of drivers, they have the likelihood of crashing into them if they are not seen and determined in a certain way, laterally or on the back. It could cause a fatal crash, or at least a very serious crash. While a motorcycle, if it is not seen by this type of larger vehicle or lighter vehicles, the same thing will happen. The risk still is present for the motorcyclists, because if they are not seen, if they're crashed into, this possibility that the motorcycles will die is quite high. So one way or another, we can see that if trucks or motorcycles are not visible towards other types or drivers, at the end of the day, the driver of the motorcycle is always going to get the worst of it from the crash. So for a long time, I've been studying, actually it's been from the 60s, how reflective technology can help visibility of vehicles. And we've implemented a lot of global level regulations towards what we call the larger vehicles, and we have seen attempts to replicate this model for smaller size vehicles due to the high presence of this type of vehicle, the conditions that they are facing within the road. A lot of time they're not really visible. So the results of this implementation that has been studied in several parts of research on a global level, especially on Asia, where there's a much higher amount of motorcycles than other regions in the world, we can see the results are that there's going to be less accidents, improved safety for drivers and other types of users. Some examples of marked motorcycles that can help to reduce the amount of crashes here, especially in situations like this, where the vision of the motorcyclist is obstructed due to the lights of the vehicles. Generally, motorcycles only has back and front lights, and in these circumstances, in a 45 or 90 degree angle, the driver of the vehicle will only be able to see the side of the motorcycle, and if they do not possess high visibility elements, they will not be seen on time. And this is how we get the amount of impacts among types of vehicles with the motorcycle that can generate the fatal road crashes with serious harm. And we will be talking about the same situation with biking culture. See that there's been an increase in cyclism in our cities, because that's great. I mean, bicycles are a means of transportation that for a long time they should have been more promoted and more used. Sadly, a lot of the infrastructure is not adequate towards people taking the decision of being able to use their bicycle as a safe means of transport. But on top of that, while the infrastructure is being implemented in our cities to give space to these new means of mobility, the cyclists must be aware of improving in a certain way their visibility conditions to reduce the likelihood of crashes. So you can see that a lot of the time the visibility, especially the visibility of that a cyclist would have, is not the same one that they have at night compared to during the day. This is why it's important for cyclists to evaluate their conditions, especially at night, to guarantee their visibility, and so they will avoid being hit or run over or impacted upon by another type of vehicle, which, as always, the cyclist is the one that gets the worst of it. So the use of reflectives is also important here. Usually you will recommend the use of protection equipment, like protective clothing and helmets. But if the helmet has no reflectors, or the clothing doesn't have it, then the bicycle should have some reflective elements to improve their visibility and detection, so that people will be in some way be able to recognize that it's a bicycle and perform some sort of braking or speed reduction maneuver. There's also research that recognizes that the normal headlights that bicycle has, they don't have the retroreflective capacities that a tape can have, a retroreflective tape can have. So you need for these retroreflective tapes to be implemented on the frame of the bicycle, so that it will guarantee their visibility. In a few countries, like in Peru, where we have the obligatory usage of the retroreflective tape on bicycles, and in a certain way this will make it so cyclists will have this relative elements and will be able to avoid accidents. There's also backlights, front lights, there's brake systems and sound systems, which are also obligatory. So we want to leave the message in a certain way that while local governments and municipalities are working on the infrastructure for this type of user, we could promote through making awareness campaigns and education for the users to assess the conditions where they will not be visible. And with this type of solution, very quickly, it's easy to implement, it's not expensive. They will be able to have better prevention of crashes. We've tried to reach this infrastructure part and the vehicle part, which we must keep in mind is a key point for our cities to be able to reach a reduction of crashes that can save lives, that will prevent serious lesions that in a lot of the time it will completely change a person's life, affecting not just people but society, their families, and especially our countries. It's very important that the message is that through technology, through innovation, that is technology can help save lives. These are proven technologies. They are low-cost engineering solutions, and with them you can change the road safety of our infrastructure and our vehicles in a high degree. And with this, we want to finish our presentation and want to thank you all for your time and your disposition today. So, questions? No. Thank you very much, Malu. We are very thankful for your presentation. But also to you, Salvador, Victor, Paula, and now we will we have a few questions here in the chat. You can see a few of them here. It seems that the government thank you for your presentation. The road markings are a good option to improve visibility in the project, but most of the materials used in Brazil, they reduce attrition and increase the accidents with motorcycles. What technologies that increase visibility are the marks that don't reduce attrition? What is the percentage of them that cost the most than traditional material? Can you clarify that for a few, for at least one of our friends, that what would attrition means without, I believe it might mean a reduction of friction. I believe that what attrition is talking about. Bruno, would you know what that means with attrition, with atrito? From what I understand, must be related to the reduction of sliding. That's what it's talking about. This microphone is very low. Friction. I'm sorry, his microphone is very low. Cannot hear what he's saying. I don't know if you want to answer. There is a coefficient that measures the minimum coefficient of friction, commonly road markings as a material, basically commonly longitudinal line will be between 30 and 35 BPN, and it has a marking, a road marking that is transversal, utilized for vulnerable users like pedestrians and pedestrian crossings or bike lanes or motorcycles. A lot of the time in urban zones they transit on pedestrian crossings, they must be above 40 bpn. They are aggregate materials that can be placed on road markings like as such to increase their friction level. And in 3M we use a solution that are pavement tapes for road marking called stigma, which are used for pedestrian crossings for marking and the longitudinal markings, arrows and markings which have an elevated value. Around 40 and 45 bpn is the friction coefficient they can find in this material. So basically there's two options. Or apply paint with additives that avoid sliding on these types of markings, or you apply preform elements with the preform tapes that from the start they already have a friction coefficient that's pretty high. Of course, this must also accomplish some performance levels or the photometric characteristics. They must maintain their color, must maintain their retroreflectivity, their daily reflection, and night reflection. I hope that with this we'll be able to have answered the question, and well, there is documentation that can be shared, indeed, if you want more references. Thank you very much. Thanks, Salvador. On top of that, I would like to add, and getting ahead of another question about rain conditions. These types of elements, stain marks, tapes that can be visible and can meet their friction requirements to avoid crashes. There are some series and models that have this retroreflectivity underwater. So in humidity situations that are covered under rainfall or constant or water constantly, we will still have return of water. It's something that 3M always looks for. The technology will be visible under any condition, especially in cities that we know that the rainfall condition on the year are quite elevated. So we need that in these situations, this type of technology must work even underwater. Thank you, Salvador. Thank you, Malo. It has another question that Akoyani, actually it's a comment, is horizontal markings through application products are not visible enough on the rainfall or nighttime. So on this comment, I could raise a question: what kind of technology is there so that this type of horizontal signaling will be more visible during the rainfall or during nighttime? Well, go ahead, Mel. Yeah, well, actually, all these technologies, they're not conventional technologies. Generally, when we signal horizontally on the pavement in urban zones, we use liquid paint or thermoplastic paint, and we use optical elements. The most well-known are glass microspheres. 3M goes further, and today we develop technologies with ceramic elements with refractory indexes that are higher. So we know a bit about the microsphere technology. They can have refractive indexes between 1.5 and 1.9, which are being visible only in dry conditions due to this type of refractive indexes. So if today we take a look at the technology that 3M is working on to improve the optical elements to be implemented in a type of paint, or our tapes which are self-adhering to the pavement, we're talking about refractory indexes that can be between 1.9 and 2.4. So it's a much higher range, and it allows us for these refractive indexes to push back light even when they're covered in water. So the answer there is that this improved technology, this innovation makes it so that we have solutions that will give back visibility under rainfall conditions, not just visibility in dry conditions or dry, also humid or constant rain conditions. As I said, technology is developed within elements that are developed in paint or also the tapes that will be taped on the pavement itself. Let's to add to what Malo was saying. I placed on the chat, there's a link there where you can find a technical bulletin for the improvement of visibility on all weather conditions. And you can read a bit more about how it works. And if you have any further doubts, then we can answer them right here. Thank you very much. Salvador Malo. It's a question I had, by curiosity. Malo, you mentioned about the reflective tape on bicycles, which are obligatory. Have you seen this obligatory use in measures in other places, especially in for heavy load trucks, especially during nighttime? They can be vehicles that are very dangerous on roads. Both, yes, Alejandro. Actually, the regulations of vehicles, I'm going to start with the passenger vehicles and road vehicles. The regulation, a lot of countries in Latin America, they're actually obligatory. It's been working through regulation. This regulation comes from the year 1999. The oldest ones are from Argentina, from Peru. You have regulations in Central America and Colombia. That is the last country that has adopted the regulation. Now you can see that there is, in a certain way, there have been national, international studies that demonstrate that this is related to a reduction in the amount of crashes. In the case of smaller vehicles in Peru, this regulation is very new. It's from the year 2020. It's actually started to be enforced in a couple months, and the idea is to have this reduction in the smaller vehicles. On a global level, there are some guidelines like the ones in Belgium and a few states of Canada, like in Ontario, where the use of tapes is required. We saw that in India there was some regulation for bicycles. In the case of motorcycles, it's being worked a lot with the Asian Southeast, where the use of bicycles is very, very common. So if there are examples of regulation and studies that try to imitate these research of the use of vehicles that date from the year 1963, which is pretty old technology compared to what we're seeing today, where there was already a significant reduction of the amount of crashes and victims and deadly crashes with large size vehicles. This research is ongoing. We've had studies from 1963, from the 80s, and as well as regulations that came out first, that came out of the US, and especially the European regulation, which have been the most demanding ones when it comes to the amounts and type of technologies, and have had as a consequence the ability to implement this type of regulation in smaller vehicles. Thank you very much. There's another question here, so we don't go over time. Another recent one. So the lights were designed for four-wheel vehicles. What about other segregating elements? Since these buoys, these separators, are considered to be dangerous for cyclists and motorcycles. Well, they do not have an angle where they spin on the wheel's angle. A lot of the time they just sort of deflect the wheel. And commonly the segregation that are safer for cyclists, well, there is a number of elements, but they are the ones that they allowed for there to be a physical separation, especially for vulnerable users. And compared to vehicles, there are a number of ideas such as the speed bumps, the concrete speed bumps, separators that are approved by the Federal Highway Administration, where a few separators can be based on recycled wheels using recycled reflective elements. So what I will look for is to have a physical separation that increased the level of security for the users, and that would also, in a certain way, they would not cause a lesion. Commonly, the use for these separators are not as speed reducers. They are also elements to go over them. They're used for separation, or the widening of lanes. So there are a number of elements that can be used. These boys are metallic speed bumps. One more question I saw somewhere in here. Here in Merida, from 10 years, we've had using red reflective tapes since 75% of the signaling are not reflective. It's had good results. When you see when we power goes out, when we lose power. Well, to add to that, I'm going to look for the information in the chat. There's actually a countermeasure, a solution assessed by the Federal Highway Administration. The inclusion of reflectives on the posts and signaling posts, where it just doesn't just help to re-visualize this signals and the cognitive process we're talking about here, but it also gives you a different element which is important to be about the visibility, was the notoriety. When we talk about the cognitive process, we can see that there are several stages to be able to understand what a road sign says. The first one is to have a perception. After perceiving something, we have visibility. After having visibility, we need to have legibility, and when we have a conjunction of perception, visibility, and legibility, we have all the info to be able to take a decision. The inclusion of these tapes on the post, you'll be able to see it on their surroundings, and it's a pretty well accepted countermeasure, especially in critical points like crossings, places where there is a high amount of accidents. I think Malo may be able to share a link where you'll be able to see this countermeasure, which is quite similar to what is being happening in Merida. So on average, we continue with this practice, we can have a regulated zone, and it will comply with any necessary levels of visibility during daytime or nighttime. So the evolution towards reflective signaling will have a good impact on the safety of the road. Thank you very much, Salvador. So, last one. The question is, have you included signaling that is not sexist, like crossing signs with icons of women and men, etc.? Malo, if you want to answer that, just to tell you, this pictogram thing is derivated a lot from a lot of research. of signs that represent figuratively a real object. So the pictograms, they're an evolution for many years now. They've been an evolution basically of a nonverbal language, of a system of writing. The first being convened to homologate this, and there's an inclusion of this there's an evolution of this sign system as it is. A lot of the time they are designed to facilitate reading at high speeds and maintain, well, the pictograms as simple as possible and with highly recognizable icons. So that's been the standard for a long time. This is not a good or bad thing. There is a technical study behind it. There is an amount of height, so we technically call it, it has a high rate of legibility for a certain height and dimension based on the distance of visualization. So to modify these pictograms is not that easy. It doesn't mean it's impossible, but it takes a lot of effort and to assess that they account for legibility indexes, and they have to have this worldwide standardization law. It's not something that 3M does. It's on part of the authorities, but basically is also subject to changes and evolution that may be needed. For now, the pictograms are standardized. For instance, in our region, they come from part of the Inter-American Manual, and from that manual, and that's where they're standardized, these pictograms. So for now, there is no intention of including signaling that is for women and or men, or non-sexist, as you put it. I don't know if that clarified it a bit more. Yes, just to mention some examples. Thank you. Maybe there are initiatives of that are in the individual efforts from local governments, like Salvador said. It's not closed, as you saw. We're talking about the guidelines, but we also think that this type of initiative needs to, in a certain way, promote that these studies happen, an evolution, so that there is, just like in the case of school zones, that we differentiate the boy from the girl, maybe also in pedestrian crossings. But it's part of a process that we believe today are being added to this type of effort. Thanks, Mel and Salvador. Well, last question. Thanks. There are school cross where the height of the knees there are two horizontal lines. What do those mean? Because there's some that don't have those lines. In the case of school zones, you can find of the three types within a single manual. One that does not have it, which is basically where it warns you that you are at a distance of a crossing of a school zone. It warns you that the school is not just a school zone, but it's a school crossing. But under intersection, that's where the kids pass. So there's a date on the lower side that indicates that that's where the crossing is. So the difference between not having it and having it is that one warns you the presence of a school zone, and having both of the lines allows you the presence of a crossing when there are school kids there. So that's the difference. Yeah, that's right. Maybe just to add to what Mel said, a lot of the time legislation in our region requires for a school zone to have a start and end, because a school zone normally has well, a restricted speed. A lot of them use different road guidelines in other zones, and generally the ones that don't have those lines are indicated the start and the end of a school zone, and the ones that have those are to indicate exactly where the pedestrian crossing is within the school zone. Maybe that will be able to help you to understand what it is. Thanks, Salvador Morales. So with that, we're out of time. We finish our session with 3M, and we want to thank you a lot for presenting us these subjects. A few of those that we don't mention normally, like signaling and reflectivity. And well, we'll have the slides and presentations will be in English, Portuguese, and Spanish, just like the recording of the presentations on our Vision Zero website, webchallenge.org. So these webinar presentations that are right here, and so that you're up to date with the activities that will be ongoing in the future with these series of webinars. We'll be able to continue working with all of you, 3M, all these cities. Thank you for having accompanied us today to reach this goal of safe programs and Vision Zero and save lives in our region.